Have you ever looked at a distillation column and thought, how does this giant metal tower even work? Well, today I'm going to show you that a distillation column is actually a whole city. Yes, a city designed to separate different citizens based on how easily they escape, also known as volatility. In just a few minutes, distillation won't feel like chemical engineering, it'll feel like real life.
Imagine a tall building, 20, 30, maybe even 60 floors. People enter the building from the lobby, and depending on their personality, they move up or stay down. In our distillation city, light, energetic people represent more volatile molecules. They love to climb up. Heavy, lazy people represent less volatile molecules. They stay at the bottom. The building has stairs going up, which is the vapor rising, and escalators going down, which is the liquid descending. Every floor has a checkpoint, just like trays or stages, where people can decide whether to go up or down. And slowly, floor by floor, the building separates them perfectly. Before diving deeper, we need to understand two types of problems engineers deal with. Number 1. Design problems. This is like building the city. You don't have a tower yet. You want to know, how wide should the building be? How many floors do we need to separate the people properly? How much cooling and heating will we need? This is like planning a brand new skyscraper. Number 2. Simulation problems. Here the city already exists. The tower is already built. You're basically asking, with this number of floors and this size, how well can I separate the residents? You check if the elevator vapor velocity is too fast or if the escalators liquid are overflowing. Understanding whether you're doing design or simulation changes everything. To run this city smoothly, we need to control some key variables. First, pressure P, like the weather of the city. Second, feed flow rate F, how many people enter the building. Third, feed composition, ZF, what percentage of energetic versus lazy people. Fourth, feed temperature, TF, are they entering hot or cold? And finally, reflux ratio, how many people on the roof are being sent back inside to help separation. These variables decide the city's performance. Let's apply logic to our city. Imagine 1,000 people enter the building. They must leave from either the rooftop exit distillate or the ground exit bottoms. This gives us the simple rule. Total mass balance. F equals D plus B. If 1,000 enter and 600 leave from the roof, then 400 leave from the bottom. Simple. Now for the component balance for the more energetic people. The energetic people prefer going up. So if 40% of the feed is light components, the equation is ZF times F equals XD times D plus XB times B. This helps us calculate D and B directly. But the city also needs energy to function. Two places use energy. The bottom reboilers, like a giant heater sending energetic people up. The top condenser, like an AC cooling down people living. Using the first law of thermodynamics, QC plus QR plus F times HF equals D times HD plus B times HB. This tells us how much heating and cooling the building needs. Then we can isolate each term to find the condenser duty, QC, and the reboiler duty, QR. These values tell us how powerful our heater and AC must be. Every floor is a mini negotiation zone. The rising vapor tries to convince the liquid to send more energetic molecules upward. The liquid tries to convince heavy molecules to come down. This negotiation is known as mass transfer. The more floors or stages we have, the more negotiations happen, and the better the separation. So there you go. A distillation tower isn't just a metal tube, it's a whole city of molecules being separated by their personalities. We used mass balances, energy balances, reboiler and condenser duties, reflux ratio, and the idea of stages to understand how the city works from top to bottom. If chemical engineering always felt abstract, now you know it's just like real life. Thank you for watching. If you liked this creative explanation, don't forget to like, share, and subscribe. See you in the next video.